Hello, my name is Darío, and today I'm presenting my oral exam from electrical circuit analysis. Here's the edit code. Here's the first scenario in which we want to build a circuit in which we have a LED, and we have that a LED works with from 1.8 volts to 2.4 volts, and the LED needs from, well, in optimal conditions, 20 milliamperes, and maximum conditions, 120 milliamperes. The circuit would look like this, in which we have a power source of 8.7 and a current of 20 milliamps or 0.02 amps. Well, at first, we need to calculate how much voltage we have in the resistance, and we can get that resting, or yes, 8.7 volts minus the 1.8 that a LED uses in normal conditions, and we got that the voltage in the resistance will be of 6.9. And then by Ohm's law, we make a division, 6.9 volts by 0.02 amps, and we get that the needed resistance for that point in these conditions would be of 345 ohms. Here is this question that if we have a 220 ohms and 100 ohm resistance, if we can use it in the past circuit, and the answer is no, but we can make some changes as I did here, also with Ohm's law. When we use the maximum current permitted, we need a resistance of 57.5 ohms, and we can change the value of the resistance between the maximum and the minimum, and we will get values of minus 300 and between 57.5 and the 345 that we got before. So we can use any of those values of current to build the circuit with this resistance mentioned here. Then we have this scenario in which we talk about defibrillators, which are components or gadgets that many people use when they have a problem in their heart, and it works like discharging shocks in the heart for making pulse. And we have that modern defibrillators can now deliver from 150 joules up to 360 joules per 20 milliseconds. And then we have this first question in which we have to explain which variables we use. And then we can explain how much you can discharge from a defibrillator by the power, which we can get it from dividing the work by time. And we have how many, well, as the formula says, how many power we are discharging on heart in a period of time. Then this question says, what is needed to guarantee that a defibrillator charges in 10 seconds at the most? And I think it's that have a good and constant power source, because if you don't have it, can fail. And also have the less resistance as you can have without damaging the system, because in all the formulas of charging, as resistance is dividing, if the value is lower, we will have a bigger, faster time. Here exposes a case in which we want to make a reactivation, and which will be the fastest way. I think this can be, if we have the less resistance, we will have the most current. And I think this works like in hospitals, that they do electroshocks that to people that is almost dying. And I think the clue is having no resistance or having the less. So you can have the biggest discharge on heart, and that's when in some occasions it's crucial to save lives. Then this question asks us to calculate the power that a defibrillator dissipates in each shock with the minimum energy in the range that we have, that the minimum is 150 joules, and the maximum is 360 joules. So for power, we divide work by time, and we have 150 by 0.02020 seconds, and we get a power of 7,500 watts in this situation. And then here we have a question that says that we have to mention two factors that can prevent the heart from receiving enough current for the reactivation of the heart rate. And I think this can be because of an error of the battery. You need to have, as I mentioned before, a good and constant power source. And also, in some occasions, this gadget has inefficient or over detections that can make that you don't receive enough, or you receive more shocks than the ones you need, and this can all affect the health of the patients. So thank you very much, and that's all.